DFMEA, guys, you might have the question in your mind. This is a general question. Okay. Have you ever wondered how engineers make sure that the things we use are safe and work well? Whether there is a question in your mind that how engineers make sure that the things they are creating that are the safe and it will work well always. So if that question is there in your mind, then engineers use this tool called DFMEA, that is Design Failure Mode Effect Analysis. This is a tool, okay, that is not an analysis tool, guys, okay, that is not a FEA analysis, okay, that is a DFMEA, Design Failure Mode Effect Analysis. And nowadays, each and industry uses this DFMEA. Okay, so let me go into the introduction of the DFMEA. As I said, it is a full form of DFMA is a design failure mode effect analysis. Every industry uses this tool nowadays. Okay. So it's tool used for the finding and fixing problem in early stage. In very simple words, okay. Suppose you are designing XYZ product. Okay. Try to find the problem in that product in early stage. Based on my experience, I think this problem will occur in this part. And try to fix that problem in early stage. That is called DFMA. That is the, we can say, purpose of the DFMA. Okay. So it makes the product or part better and safer before creating them. Every industry uses a DFMA nowadays, as I said already. Okay, this is just introduction. And why engineers uses it, I already explained you. Okay, the first thing is safety. Engineers wanted to make sure that the part they have created, those are the safety to prevent the accident and harm to the users. Quality, obviously, engineers aim for products that works well and last for a long time. Okay, if you purchase a car, suppose, and if that car works well just for 1 month, are you going to recommend that card for any other your colleagues? No, right? That card should work at least for 10 years, 15 years. And engineers use DFMA tool to make sure that it will last long for a long time. Okay. Then the third thing is fewer problems to lesser the problems. Very less chance of the product breaking and the working. Let me make it clear. DFMA tool will not eliminate your 100% problem, but it will minimize those problem or minimize the severity of this problem. Okay, so you got just initial introduction of the DFMA, right? So guys, here what I'm going to do, I'm going to share the general steps of the DFMA. Then we'll take the real life example, how to run the DFMA on that real life part, so that you will get a clear idea. Okay, and this is a standard template I'm going to share. Okay, so which is used in the industry. So these are the 10 steps, general step to run the DFMA, that is the design failure mode effect analysis. The first one is team up. It is not a work of just single person. Okay, it is a work of the team. So you have to build a team. Build a team. Your team should consist of designer, product engineer, manufacturer, purchase, then quality. Everyone should be there in your team. At least one member of that team should be there in your team to run this DFME. Then the second stage is break it down. Break it down means just break it down, segregate your part into different parts. For example, if you have assembly having the 10 parts, break it down into the 10 parts, like part number 1, 2, 3, 4, something like that. If you have a single part, break it down like top area, bottom area, left area, center area, something like that. But break it down, segregate your parts. Next stage is a find problems. Just brainstorm and based on your experience, find the problems. You have this product and based on your experience, okay, this problem, I think this problem may occur in this part. Just list down the problems based on the experience of the designer, product engineer, or purchase or quality. Take everyone's input and list down the problems. Once you have problem list, rate those problems based on the severity. I think this problem is very severe. Just give the rating out of 10, like rating 9, rating 10. This problem is less severe. Just give the rating as a 3, 4. So based on that, assign the rating based on the severity of the problem. Stage number 5, effects. List down the effects of those problems. If those problem is going to occur in that part, then write down the effect of those problems. Okay. Then the stage number 6, write down the actions, what you are going to take the actions on those problems, so that that problem will not occur anymore in the future. So list down the action steps. Okay. Then the step number 7, prioritize. Based on this rating, decide the priority. This is number one problem, I should work on this first because this is very severe. Then second number, third number, based on that, prioritize your problems and work on that. Okay. Next stage is make a changes. Based on your action items, make a changes in your part. Next is again, once you make a changes, run that product, create the product, and run your DFMA again after I think few months. Okay. And last stage is keep repeating. DFMA is not a one, we can say, it will not, you are not going to feel it in one go, because in the initial stage of the product development, you are going to feel the DFMA. Once your product is created, again feel the DFMA. Once your product is in the production, again feel the DFMA. Okay. So in the multiple stages, you have to feel and update the DFMA again. Okay, so these are the 10 general steps, and I know you guys have got just the idea, but still you have confusion in your mind. I know, guys. Okay, and that's why here I'm going to show you the real life example. Okay, so here I have not selected any mechanical component to avoid any confusion. So I have selected this real life component here, plastic chair. Everyone have this type of the chair in their home, right? And that's why I have selected this chair to run DFMA on this chair. Okay, so I'm going to share the standard template here that is used into the industry to run the DFMA. So we are going to use that template and run DFMA for this chair. Okay, so let me expand this. So I have this template already filled here. Okay, just for example, I have listed 3 problems here. You can list more, like 4, 5, 6 problems also. So the first column will be item information. Item information of this item. What is this item? Part name, plastic chair, right? Part number, what is the part number defined by the company or the OEM? Then date, the date of running the DFMA. This is very initial information, right? Write down the function, list down the functions of that part. What is the function of the plastic chair? Provide the support to the person sitting on this, right? Distribute the weight evenly, obviously, and provide the comfort during the use. That is the function of this chair. Agree? Now, next column is potential failure mode. That is the important first stage of the DFMA. List down the problem. List down the potential failure mode. It is not important that it will happen, okay, but what you think that may happen. So, cracking of the plastic, that is the first issue. I think plastic may crack from this chair. So, that is the first issue I have listed here. Second thing is a seat shape deformation. This is the shape of the seat, right? This shape may deform. Okay, that I think that problem may occur in this chair. And uncomfortable design. I think the design of this chair is uncomfortable, so that user who is using this chair, that is uncomfortable for him. So these are the 3 problems I have listed here. Just for example, you can list more problems. Okay. Once you have listed the problem, write down the effect of those problems, effect of those failure. What will happen if the plastic is going to crack? It will be reduced safety for the user. Okay. What will happen if the seat shape deform? Then that is a shorter lifetime of this chair, right? And uncomfortable, that is a discomfort for the user. That those are the effects of this problem. Okay. Next stage is you have to define S. S is a severity. Severity of this problem. I think cracking of plastic is very severe. So based on my experience, I have defined 8 rating out of 10 here. Okay. Then seat shape deformation, that is a less severe. So that is 7. And based on this, I have defined is as a 6. Okay. So you have defined the rating. Now, potential causes. What I think, what are the causes of that problem? What are the reasons of that problem? So why plastic may crack? I think low quality plastic material is used, and that's why plastic may crack. I think insufficient reinforcement is there, and that's why seat shape is deformed. What do you mean by reinforcement, guys? You have seen this, right? Underneath of this shape, there are a lot of ribs to support this shape, right? So I think those ribs are not sufficient to support this shape, and that's why I think this is a reason of this problem, insufficient reinforcement, right? Third is inadequate ergonomic design. So I have not considered that ergonomic design, so that this is a discomfort for the user. Okay. And occurrences. Now you have to define the O there. Occurrences. Occurrences means what you think how likely that problem will occur out of 10. For example, I have 10 chairs. So I think out of 10 chairs, in the 7 chairs, that problem will occur. So I highlighted rating as a 7 here for the occurrences. 5 here and 6 here based on that, based on my experience. Okay. Then current controls. What are the current controls to control the problem? So regular material quality checks will be there to improve the quality of the plastic. Reinforcement rips in design. So I have to add the reinforcement so that it will not deform the seat shape, and basic ergonomic guidelines follow. Okay, so I have to consider that. These are the current controls. Now you have to define the detection. Detection means how early it is going to be detected. That means, for example, I am designing the chair, and while designing that chair, I thought this problem may occur. Okay, so in designing phase itself, that problem is going to occur. So that is not that much serious because my tools are not kicked off, my production line is not running. So at that time, if problem is occurred, or I think that problem may occur, so you can define the rating based on that. If suppose your chair is in the production, tool are designed, production line is running, and at that time you thought yes, this problem may occur, and considering that you have to change the tool, you have to change the production line, so that will impact your cost, right? That will increase your cost, and that problem is very serious. At that time you can define high rating here as a detection. Okay. Now you have to calculate risk priority number, that is a RPN, that is a multiplication of this SOD, that is a multiplication, and based on this, you are going to define the priority of working on that problem. So multiplying this is my number one priority, as this is bigger number. This is my number two priority, and this is my number three priority. So I'm going to work on this, and then this. Okay. So what are the recommended actions on this? Just list down. So use high quality plastic material so that that plastic will not crack. Increase the reinforcement drip underneath of this seat so that that shape may will not deform. Then improve the ergonomic design based on the user feedback. Directly take the feedback of the user and improve your ergonomic design so that it will feel comfortable to the user of that chair. Right now, you have to write the residual risk. Guys, as I said, DFMA will not eliminate your 100% problem, but it will minimize the risk of that problem. Currently, okay, previously the risk was, you can see the severity was 8 here, but now after implementing this problem, I think now severity gone to the 4. So that is the residual risk. Okay, so after implementing this, I'm not sure, means problem, plastic may crack, still plastic will crack, but severity is 4 right now. So it is a residual risk you have to define for all the problems. Now write down the action owners and the due date on working on these problems. Okay, and verification. What verification is going to be done? Whether that problem is going to be occur again, or that action item involved or implemented. Okay, so conduct the material testing regularly, perform load test analysis, and gather the user feedback to get the better ergonomic design. And as I said, last stage is review DFMA again after 1 month or 2 months. Okay, so this is a standard template of the DFMA. I will share the image in the WhatsApp group, but I'm not sure whether it is clear or not because it's a very big image. But you have the standard template, guys. You have the standard template in your workbook. Okay, standard columns. So this is a standard template used in the industry, and nowadays they are using the softwares for the DFMA. Okay, software is, you don't have to learn the softwares. One of the software is there called Stature. Okay, I know the software, but every industry, every company uses different software. So don't focus on the software. Software is nothing but a DFMA software. They have already their own database. That means, for example, as a OEM manufacturer, as a chair manufacturer, I already manufactured a lot of chairs previously in the past, right? So I know the functions of this chair. Okay, I know the potential failure modes. So those points are already available in my database. So I'm going to select those points from my database and will fill here. If I wanted to add more points, and I can add more points here, but the software is just using the database. Okay, so I hope it is clear, guys. Any question for the DFMA, design failure mode effect analysis? If it is clear, type clear. If you have a question, Just type question quickly so that I can answer in the few seconds. Okay. I'll try to export this guys for you guys as a PNG. Meanwhile, you can type question. Please explain RPN. Dipesh is asking. Other guys are saying clear. Yes, give me a second. I will explain the RPN here. Okay. So that template is dropped into the WhatsApp group, guys. Yes, Dipesh, I'm explaining the RPN. Just give me a second. So RPN is nothing but it is a risk priority number, and you are going to multiply this SOD, that is severity, occurrences, and detection. Just multiply this all the factors, and you will get the numbers. Okay, based on that number, you are going to prioritize those problems. Okay, it is just to decide the priority of these problems. Okay, because you have to consider detection, occurrences, and the severity. You have to consider all these factors and define the RPN. Clear, Dipesh? Let me know if it is clear. Guys, if you have any question, please ask. If it is clear, just type clear. Picture is not clear. It should be clear, but later on I will share again. Okay, it will take more time again because this is a bigger picture. I will send the PDF file after this workshop. Okay, don't worry.